Hello, this is Jesse, and today we're going to be going over protein structure prediction tools and more. So, first we're going to go over secondary structure prediction, and then alpha helical wheel diagrams, and then we are going to finish up with homology modeling and tertiary structure prediction and de novo structure prediction of a protein. So, what we're going to do is start off with the sequence I already gave you. And once you take the sequence, copy and paste it, open up this URL here. After you have it open, you're going to input the sequence into the input box and click Make Prediction. And then you're going to get your results back. Okay, the results are going to be right here. If you need to interpret the results, you can click on Help and Tutorials. You can click How to Make a Prediction and single sequence from a single sequence and what the output means. So this will load, and you can go to slide 14 or 15, I believe. Oh, here it is. Slide 16, actually. So here you get what the results, this is going to tell you what they mean. Okay, so you have the different results here and the interpretation. So here, notice the characters below. So we have E, H, B, and then we have this dash. So the H is going to be helical, we have the E for extended, then we have this dash sometimes for exposed, meaning exposed, and then B for buried. If we look at our results here, we just have buried, and then the dash can indicate exposed here. And then we have the actual confidence of the prediction here, the confidence. So the higher the number, the greater. So the results are showing that they have high confidence that in this region right here, there's an alpha helical structure. Low confidence in this region, low confidence in this section right here, 0, 0, but decent confidence in this section with the peptide or the beta strand structure. Low confidence with the alpha helical structure here, and then low confidence, this beta structure here, and then at least low confidence, but some confidence. There's some sort of confidence here about the beta strand here. And then, like I said, these are just buried, showing that this alpha helical structure is most likely buried within the protein structure. Okay, so that's JPRED for you. In your homework, you might be asked just to predict the structure, the secondary structure, and you can use JPRED and then validate, like there's probably going to be a alpha helical structure within this region based off of the high confidence from the results. But maybe not so more of beta strands in the structure based off of the low confidence. Or maybe there's only going to be one alpha helical structure compared to these lower predictions here. Very low confidence in this prediction, very high over here. So most likely there's going to be an alpha helical peptide or alpha helical structure. Next we can go over into a different secondary structure prediction web tool. And you just open up this link and you can copy and paste the protein sequence into the input box. After you click submit, you're going to get results back. And here in JPRED, you would have to go back and look to the tutorial section to interpret the results if you forget or don't know what the symbols mean. But in this case, they're going to provide you the statistics and the percentage of the alpha helix occurring to predicted alpha helical section, and then other features of this structure after the structure has been analyzed for secondary structures at least. So here we have random coils. These C's will just be random coils, and then we have these regions which are going to be the extended strand. And then we have these H's right here, which are going to be helix, or alpha helix, and you can say this is 47.14%. So this is high chance that there is going to be an alpha helical structure in this protein. Okay. big chance it's going to be alpha helical structure in this region. And then same with the random coils. We have high confidence here in these regions. And so this is JPRED. Now, or this is PhD. Now you can notice that there's no sort of beta structure predicted in this in these results. As compared to JPRED, there is some structure prediction. There is some, at least they have some sort of confidence, very little, but some sort of confidence that there might be a beta strand or beta sheet, sort of some type of beta structure in this protein. Okay, so this is just showing you the different. They're both predicting the secondary structure of the protein, but some of them don't have the same results. So you might need to use several different structure prediction software or interfaces, web interfaces, and you can help get you can figure out a general consensus. For instance, in this case, there's probably a high chance that there's going to be a alpha helical structure in this protein based off of the PhD results and the JPRED results, right? So that's secondary structure prediction. Next, we can go over alpha helical, creating helical wheel diagrams using an alpha helical peptide. In this case, we're going to be using secondaryP A. So you can open up the URL that I've given you here. Open up, you're going to input your sequence, and then for window size, you can go to full, and then you can click process, and then it's going to give you several diagrams, helical wheel diagrams. So notice how we're starting at position 1 and going to position 54 because the window size, the full window size length is 54 as the max length. So it's going to give us within this window size the alpha helical diagram. And then from here, you can notice from the other ones are from position 2 to 55, and it gives you the alpha helical diagram. So you can see the amino acids that are on the outside and the amino acids that are in the inside. Okay. And then also gives you some additional information about the analysis, the parameter, the properties of the protein. So here we have the hydrophobicity, hydrophobic moment, the net charge, the hydrophobic face, and you might be asked different questions about what's the hydrophobic face of region 5 through 58, or from X to Y. Additionally, there's other software or web tools you can use to create a helical wheel diagram. So you can type in emboss pep wheel, and you can use emboss's web interface for creating a pep wheel or a helical wheel diagram. So in this case, what we're going to do is, I already have one opened up and I've already inputted the sequence, and additionally it's going to label sequences or the amino acids a certain shape. In this case, I put squares as hydrophobic, I put diamonds as polar, and I put octagons as charged residues, and then I have the tryptophan here as just an other, because in some cases it could be hydrophobic. It also occurs, it can also be polar. So I'm just going to run, so I just put this one there. I'm going to run the pep wheel, and then here it creates the wheel diagram, the helical wheel diagram. Okay, so notice that on the outside of this protein, of this peptide, we have a lot of charged and polar residues, right? Charged polar residues. Okay, and then on the inside, solely hydrophobic, or maybe we have like 2 that are polar and 1 that's charged. But in this case, mainly is just hydrophobic, right? We have leucine, alanine, methionine, valine, phenylalanine, isoleucine. So these are highly hydrophobic in the inside, which makes sense. We can also look and start talking about how that the water is probably going to be excluded in this region, and how on the surface it makes sense that you can say that the outside is mainly going to be hydrophilic, right? Because there's a lot of polar residues, and there's some that are charged too. Okay, so that's the helical wheel diagram.